Let's go ahead and open up QGIS. If you've downloaded and installed the program, you'll have this folder here, QGIS 3.16. Double click here, and you have QGIS Desktop 3.16.1. Double clicking that will open it right up. And it will also show up here. You can also access through the Start menu down here. Here it's recently added. I've just installed this version, so there it is. You can also type in QGIS Desktop. If you're on a Mac, it will be a little bit different. And I can't help you at all because I don't have one of those here. When it opens up, you will see New Empty Project, and that is just fine. Double click on that. And now we have a nice scary blank screen. On the left, you should see this Browser tab here. If you don't, View, Panels, Browser. That browser is what allows you to sift through all your files and find where you've stored your data. I've stored mine in the C drive, GISNT. Keep opening these up. GIS 300 datasets, week 1. One way or another, I will get this folder to you. So I have the option to double click, and it's telling me that it wants to be in NAD 1983. UTM Zone 19 North, which is perfectly fine and good. I can just go ahead and say OK. There we go, and there's on my GPS tracks. I can double click on the next one. There's my lakes and ponds. Double click on the next. There's the DOT roads. Double click on that. There's my raster. That is the statewide 10-meter DEM. Double click on that. There's my sensor points. There's my streams. There's my watershed boundaries. Now, first thing I have to do is draw these things in order. They are appearing in the order I clicked on them, and we have the elevation model hiding half of the data. So elevation model to the bottom. Let's put lakes and ponds just above that. We'll put watershed boundaries here, and we'll just put the points on top. And this is the most common order to have these things in: points, lines, polygons, raster, or base map. This changes. There's reasons why you break that trend, but that is the usual sequence. Now we have the issue of red lakes, and we hope that the lakes are not red. We hope that the streams are not orange, and it's okay for the roads to be orange, but the streams ought not to be so. So let's go ahead and change some colors here. So I see watershed boundaries. That's something I don't care about right now. I'm going to actually uncheck that, so we can leave that for later. But let's go ahead and deal with our lakes and ponds. If I double click on that square right there, I have the option to change this, and I have some options here. Here's a simple blue fill. I can apply that, see if I like it. Hit OK, zoom in. Do I like that for a pond? Maybe, maybe I don't. And we can see these lines for the streams are going through there. There's a reason where we might want to have the streams underneath the lakes and ponds. So we don't see them there. We only see where they drain into the pond and not where the elevation model thinks it's going to take the stream across that pond. So I don't love that. It's okay, but I want to change it a bit. So let's double click on that again, and I get more options if I go to simple fill here. Something I often do is take this stroke color or outline color, use this drop down and say transparent stroke. That way I don't actually have an outline, and you couldn't see it very well in the first place. Let's make that something a little more obvious so you see the difference here. So let's go ahead and make that a big, thick, bright yellow. And now you can see how that's drawing that outline around here. And as you zoom out, that outline becomes more and more obtrusive, and so do the other data sets. So let's make them go away for now. But you see how much yellow you see on this map when you're all the way out here? That gets to be obtrusive. You really can't see what's going on there very well at all. So let's go back out there, and now let's see the difference when I change that and say I want a completely transparent stroke. Now I only see these lakes and ponds, and the smaller ones have disappeared, but we're zoomed so far out, maybe it doesn't matter that we can't see them very well. Once we zoom in more, we can see there's the smaller ponds. There's some features we couldn't see at all. But once we had the outline on there, we could see those as big, too big really, yellow splotches on our map. So let's keep on going through here and make this map make a little more sense. So we've got our stream sensor points, there they are. And before we saw how to make those display by a color. Let's do that now. Double click on stream sensor points. And here we're in the symbology tab. And rather than single symbol, we want to say graduated. So now we're in a graduated symbology. Next we need a value. That value is going to be, let's, just for giggles, use hours over 70 degrees in July and August. And that's our sort of base symbol there. And let's go ahead and click classify. And that's interesting, fine and good, but we have too many categories here. Or we could say, let's use a different mode here. So let's make pretty breaks. So, 0 to 200, but that really doesn't make sense to us because 0 to 200, that's a lot of variation. So let's change that again and say logarithmic. No, it doesn't like that at all. Let's try equal interval. No, we still want to have something that shows really 0. So try standard deviation. No. Let's try, again, pretty breaks. Well, let's go ahead and change these values. So the upper value I'm going to make, let's just make that 0, see what happens. Good to experiment. So from 0 to 0. And we do have a lot of zeros, and that's a good thing if you're a trout. So now we have to think about how we want to do the rest of this. And I'm just going to enter in what I think the values should be, because I didn't like any of these automatic modes here. So by double clicking here, I have the option. Let's say from 0 to 50, because 50 hours is a bit, but fish can swim, they can move around. If it's just 50 hours above 70 degrees Fahrenheit, that is the threshold for brook trout where they start to get a little uncomfortable. Over 80 degrees, they start to get a little bit dead. So let's move away from that morbidity there, or mortality as the case may be, and say 100. So 50 to 100, let's getting higher. From 100, let's give it an upper value of 500. And then 500 to 1,000, 1,000 to 860. Well, that's a very small range. That really, I would bet, covers just that one point we saw before. That was pretty hot. So we have one point we know of over 1,000. So let's change that again. So let's make that 200. 100 to 200 hours, 200 to 1,000, and then we'll have that last one for 1,000 plus. Let's make it really obvious which one that is. So now if I double click here, I can change the color. So let's make that black. That'll really stand out. So we have from white, which is never exceeding that threshold of 70 degrees Fahrenheit. And then we go all the way up through this red scale from kind of cool into getting to be hot quite a bit of the year. And then this one that's just extreme. So that gives a good separation there. All right, let's see how that works. Okay. So now we have all these sites where nothing got over 70 degrees Fahrenheit, and we see that one spot here, that's the black one that got to be much too hot for much too long. But maybe we don't love that. It doesn't stick out as well as it might. So let's go ahead and double click on that. We can do that from the table of contents here. Let's change that color to yellow. Should stand out well. And we'll just remember we're breaking a bit of convention here, where normally we go from red all the way up, but that's really quite a lot of convention to break, so let's think about how we can do this. Pink should stand out. So pink, of course, green, yellow, red is a conventional color symbol. We don't really want to break that. So pink, oh, that stands out. There we go. And remember, some people are red-green colorblind, so they might not be able to see distinctions between red and green. That's about 8% of men and 0.5% of women. So now we have some color coding here, where we have this one here is quite warm. Wonder why that might be. We can investigate that later, but, well, we've got a pond right there. It looks like it drains out of a pond. We can turn on our still oddly color-coded streams here. Yes, so that comes straight through that pond, so that makes sense. But we can turn our streams back off. We'll deal with that shortly. And here we are. So we can see again some geographical trend where down here we have more warm streams and up here we have more cool ones. So that's neat. Let's go ahead and move into our streams next. Now our streams, that's a cool data set. Let's open up the attribute table of this streams and see what we've got here. Open attribute table. So we've got attributes, numbers, look completely nonsensical until you know what they mean. So the most important one is grid code. So this is the stream order. So a first order stream is where a stream first sort of trickles out of the hillside, the first time it becomes a permanent channel. When two of those first order streams come together, they make a second order stream. When two second order streams come together, they make a third order stream. So the higher the order, the bigger the stream, and the more smaller streams have come together to make that stream. So of course we have more first order streams than second order streams, and more second order streams than we have third order streams, because we're all going downhill and collecting, and the bigger you get, the fewer big rivers you have compared to the number of small streams we have. Mathematically, about 75% of the total length of streams in Maine is first and second order streams, which is what I study. So let's go ahead and close that. And just like we show these by their color, we can show these streams by their size or their order. So let's go ahead and turn those on, zoom in so we can sort of see what's going on here. So this would be a first order stream. This would be a first order stream. When they come together, they're a second order stream. This is a first order stream joining a second order stream. So this is still going to be a second order stream. But where these come together, this is going to make a third order stream. So let's go ahead and visualize that with all these data. So double click on the streams layer here. And we want more than a single symbol. We want these to be categorized. And we want the value to be grid code. So with grid code here, we want to then make these some shade of blue. Make that about like that. Looks about right. And then let's classify that. So we have 1, 2, 3, 4, 5, 6, 7. And I'm going to uncheck this all other values because we don't have any, and that's something that just appears by default. It's okay to uncheck that if you don't have anything that's not classified as 1 through 7. So the color ramp can be random colors, blues. I like to use all the same color but different widths. We set that by going through here. And let's go ahead and pick a color we like and go with that. So current color, we can pick from color swatches we might like here. We can use this system if it makes sense. We can use this triangle system. Experiment with them all, see how you like them. So let's go ahead and move, and we see down here that's where it's sort of previewing what that color is going to look like. We can move that around like that. Let's go ahead and go with that and say OK. And I would like to save that symbol, and I'm going to call that blue 2 because I've got blue 1 saved already. And I'm going to check the box that says add to favorites, save. So there's blue 2. Every time I want blue 2, I can click on that, and there it is. So I'm going to set that as a blue 2 with 0.26. Okay, now I'm going to go to number 2. And that's second order streams. I'm going to use blue 2, and I'm going to make that 0.36. Okay, I'm going to go to grid code 3, still use the same color. I'm going to make that 0.46. Okay, so we've got 0.26, 0.36, 0.46. Double click here. I'm going to go blue 2 and make that 0.56. And likewise here, so blue 2, 0.66. And then same again here, blue 2, 0.76. Okay, and now 7, blue 2, 0.86. So we've gone all the way from here, get back here, 0.26, 0.36, and so on. So now I can hit OK. And now we've categorized all these streams, and we see as they flow together, they go up in order, they get wider. Isn't that just gorgeous? We're now the Bob Ross of GIS. We've painted pretty little streams all over the landscape. And again, the exact positions of these are a little bit questionable because it came out of the 10-meter resolution elevation model, which is decades old. We have higher resolution data coming soon with the public LiDAR flight. LiDAR, light detection and ranging, 3D laser scanner, and an airplane. Very cool, very expensive, very heavy data sets, but very precise outputs. So now we see where our sensors are falling on these streams. And I mentioned before, these are streams draining 300 acres or more, and it's also there in the title. So where that stream begins, right here, that's where 300 acres of land have drained to that point. If it was 299, it wouldn't define the stream channel as starting yet. That is a legal threshold that is used in the main BMPs and the main shoreland zoning regulations. So that is a legal definition of a stream, beyond which you need to have a 75-foot buffer and work within certain bounds in forestry practices within that buffer, where larger streams draining a larger area or ponds get a 250-foot buffer. Anyway, we are definitely making progress on this map. Let's go ahead and work on our DEM next. Now, there's not much I want you to do with the DEM right now besides change it so when you're moving around it changes the context here. So this is all looking very, very drab because it's giving Katahdin the brightest white and it's giving somewhere down near the ocean the darkest black. We want to see that complete color range within our view here. So to do that, let's minimize this so that gets out of the way. See how that works? You open it up, you can see all that detail. If you choose not to display your 7th order streams or what have you, you can make those go away. Very handy. But for now, let's just minimize that. Everything's still there, you just don't have that taking up space. So double click on the DEM and let's go ahead and change how this displays. So this min-max value settings, open that up, and we want the statistics extent to reflect the updated canvas. Okay. And as soon as we do that, it's going to change. So now as we zip around, this spot's going to get the brightest white, that spot's going to get the darkest black. As we move around, it moves with us and gives us the highest elevation and the lowest elevation visualized within each view. So that's all we have to do for that. Lastly, let's make these roads make sense. So let's go ahead and check them on and check our streams off because they'll just get in the way for now, and check our lakes and ponds off too. So let's go ahead, right click, zoom to layer so we can see what we've got. And that's all the category 3 and higher roads in the main Department of Transportation database. So it doesn't cover all the little side streets, but it covers the big ones. You can see a little bit of a pattern going on here where there's more large, high importance roads where the people are. And up here, of course, there's no permanent settlement, so no DOT roads. These are all private roads, logging roads, forestry roads. There you go. Which I've driven on and recorded with my GPS. So what I want is to have these things either play nicely together or have the same symbology. Symbology means the color, the shape, the width. So let's go ahead and make this a nice red. We'll say nice highway red. We can also select a recent color from down here. So you see I've recently used this color red. I like it. So there it is. And I'm going to make that a little bit wider, 0.36. And there we go. So that is the main DOT 3 and above. And that overlaps in some places with my GPS tracks. You can see there's where the DOT says the road is, there's where my GPS says the road is, and I can either use the same symbology or I can use different symbology to let myself know that, hey, this is a different kind of road or a different kind of data. If I want all the roads to look the same, I can do that. If I want the major roads to be just a touch wider and use the same color but a different width, I can do that as well. But there are certain conventions that you would want to stay within. You would never make your roads blue, for example. Blue is for streams. Blue is for lakes. Blue is for some kind of water. But I can say, hey, there we go. We're going to use red for roads here. And I can see that the highways are a thicker line. My tracks are a thinner line. And that shows me my whole access network for all of these sites. Now the question is this data set comprehensive? Is this reliable? This is a data set that defines where Neil drove and where Neil had his GPS turned on. There is a nice connector road here, and I have just an abiding love for connector roads because it's so sad when you get to, say, here, and you could just drive up here and drive home and be home half an hour earlier, or you might have to drive all the way back here, all the way back here, all the way back out this way. So knowing where the connector roads are is very important to practice. See, we're missing a connector road here. This connects, I know it does. So I've actually got a better version of this data set. I'll give you guys the better one because this is actually an older one from 2019. I've updated this for 2020. So you'll have a better version of this. But we do not trust these things to be comprehensive. We have to check for ourselves. We have to look around. We have to look at air photos, talk to people who might know if a bridge is out. There's a spot out here. Where did I leave it? I think it might have been this one, where I got halfway up here and oh, the bridge is under construction, and I kind of wish I had emailed ahead, but I did not, so I had to drive all the way back down around here and out, and there you go. So that's the way she goes. But the advance of GIS and GPS has been such that the fundamental nature of forestry work has changed, and the fundamental nature of a lot of ecology work has changed, where there's all these things you can look for in the field in advance and say, oh, well, here's a stream, here's the buffer around that stream, here's 75 feet around a 300-acre drainage. Great, I've got my buffers figured out. I can harvest up to 40% within this area. And then you come to find out the stream moved, or the stream layer was never correct. You still have to walk out and check all these things. You are not absolved of that responsibility just because you have this nice shiny map. But that is that for now. Now let's go ahead and define what I want you to do for the hand in here. All right, so here's what I want to see for this component of week 1's assignment. So a map about like so. I want to see the streams such that the lower order streams are thinner, the higher order streams are thicker in the way we've got demonstrated here. I want to see the points showing by either the number of hours above 70 degrees Fahrenheit over the entire summer, or the mean high temperature of the day, which we've discussed before. But if you're wondering which one it is this average daily maximum in June and July. These average and max are the daily variation in temperatures, so ignore those for now or explore them, but one of these two for how we're displaying for the turn in here. So we can have the roads. The roads can be red, orange, something that makes sense. The streams have got to be blue. The lakes should be checked on, and I want to see all of that. So you'll take a screenshot. You can use the snipping tool here, or I think they've changed that a bit. I haven't updated this computer since, but you'll take a screenshot that looks like that, and I'm going to look at it for having the points here. So I want to see that. I want to see that. I want to see this done so that the brightest spot is the highest elevation within this view. So adjust the elevation model as demonstrated, and then do these in some way that makes sense. And make sure that these lakes are drawing on top of these streams so you don't have streams drawing across the way like that. That looks messy. So go ahead and do all that. Grab a screenshot. The procedure is a little different for Max, but I'm sure there's a way. Go ahead and figure out how that works. And that is the thing you're going to upload into Brightspace. And there's going to be plenty of other things to go with it, but for this component, that's what I want to see.